Graphing sums and products. Okay, so first things first, we need to talk about this one specific word, and it's called an ordinate. Now, the ordinate of a point is the y-coordinate, or more generally, the coordinate on the vertical axis. Okay, so we know that our coordinates are made up of 2 points, or 2 parts, which we call ordinates, and we're referring to this part as well. So effectively, how far up the y-axis, or how far down the y-axis are we? Okay. And so the whole idea of graphing sums and products is that we are literally going to take 2 or more, but just 2 in this case, functions, and we're going to graph them as if we were adding them together, or subtracting them, or multiplying them. And the way we do that is we literally are just looking at the y values, or the ordinates. So to sketch the sum, so s of x is equal to f of x plus g of x, so the sum of 2 functions. What you need to do is you need to start off by adding the ordinates wherever possible. So this is basically the main idea we're going to be focusing on. So add the ordinates wherever it is possible. Now, some systematic approaches that you can take to this is that if one of the curve has a 0, then the sum meets the other curve at the value of x. Okay, so if we've got 2 curves like this, okay, so one like that and one like that, okay, if one of the curves is at 0 like it is here, okay, okay, so if one of the curves is at the 0 where it is just like here, okay, so that means that when you draw your sum, okay, it's going to be on, let me do it, so it's like a function. So it's going to be, so you're going to put a point there, okay? So here's another one where it's 0, so we're going to put our point, whoop. This is actually a lot harder to do than I thought. Okay, so let's try this again. So wherever it's a 0, we're going to put our point. So there's a 0 there, so our point's going to go there. Here's a 0 here, so our point goes on the other one. Okay, here's a 0 here, so our point goes on the other one. And here's a 0 here, so our point goes on the other one. Okay, so basically, we're just putting points wherever one of the functions meets 0. So it just goes on the other one. So, you know, here's the 0 here, so it goes there. Here's the 0 here, so it goes there. 0, so it goes just where it is. 0, so it just goes where it is. But obviously drawn a lot better than that. Okay, so that's the first one. The second one is if the curves meet. Okay, so, you know, if we've got our 2 functions like this, okay, and then they meet at certain spots, then they're just double whatever the value is, okay? So in this case, this one here, so if it's this far away from here, then my point's going to be up here. This one is this far down, so it's going to be double the down. Okay, this one, they're both on the 0, so they're just both on the 0 anyway, so we don't regard those ones. So there's the first 2 things that you look at. Okay, the third one you look at, or part 4, is the ordinate of fx and gx are opposites. So, okay, so let's say we have 2 that look like this. Okay, so if we have 2, now it's if they're exactly opposite, not if they're like, you know, just similar opposite, but if they're, so see these 2 here, how they're both opposites. Okay, so then our ordinate goes in between them in the middle, okay? And last but not least, if the sign of s of x everywhere the sign of s of x everywhere will usually be clear now. So basically, if you have, you know, big positive versus, you know, small negative, so like this, okay? So, you know, here's the 0 here, so my points are between these 2 here. Okay, big versus small, so it means that I'm probably going to just have a small in between there. Something along those lines, okay? Now, to clarify any vertical or horizontal asymptotic behavior, so if f of x goes towards infinity, so if my function shoots up towards infinity, or g of x shoots in towards infinity, so my other function also shoots up towards infinity, then the sum does as well. So when you're adding them together, then the sum also shoots off. So it doesn't matter which one is, but if one of them is, then the sum of them are. If f of x is going to the negative and then g of x goes to the negative, then the sum does as well. So, you know, if my function's going this way and the other one's going like that, okay, this one's increasing down quicker, so my sum is actually also going to go like that as well. If, however, f of x and g of x go in opposite directions, we may not be able to determine what happens with their sum. So kind of like what I said with this one, like you can tell that this one's going down quicker than the other one, but we don't know what's like happening all the way over here. But as a general rule of thumb, you know, if one of my lines is like flat and one's going down like that, then the sum is going down like that. But if one's going up like that and one's going down like that, and they're sort of going at the same rate, then we don't really know what's happening. You won't be given ones to sketch like that. You will wait till year 12 before we do that. So what we're going to do first today is we're actually going to look at example 1 before we jump into the next bit of theory, because example 1 is literally just adding up adding up two graphs. So we've got y of f of x and y of g of x in these two functions here, and we need to add them up. So what we're going to do is we're going to start off by looking for the zeros. So when we're looking for the zeros, okay, I've got a 0 here and I've got a 0 here. So because this first 0 I circled, they're both on the 0, that means the point, the sum of those two is just on that one there. Okay, so think of like if I add up, so, you know, f of x is equal to 0, g of x is equal to 0, 0 plus 0 is just 0. Now this one here is a bit different, so let's say, you know, this one's at 3, for example. So this point here is at 3, whereas this point here is at 0. 0 plus 3, well, that's just 3, so when you do your sum as well, your sum goes there. Okay, so that's where my zeros are. Now to do my doubles, so wherever they cross over, so this 0 here was also 1 point crossed over, but this one over here is where it crossed over 2. Okay, so because we've got this crossover here, then that means that we need to do double of that. So that one is probably more at 3 than the other one was. So the sum at x is equal to 2 should go up to 6, which is about there. So I need to put my dot there. Okay. So rub these out. Okay, so there's my dot there. There's that ordinate. So my function, the sum of the two, is going to go through that one here. Okay, so this side shoots up to infinity and this side shoots down to infinity. We can see that y is equal to f of x is a straight line, and we can see that y of g of x is a parabola. So it's going to actually increase at an increasing it's going to increase quicker than it's going to decrease when it goes to infinity. So when we draw these ones on this side, it's basically going to go up in that direction there. Now looking between here, I've got some points in between here that are positive and some points in between that are negative on the g of x. So if I add these together, I'm basically looking at, well, I can see that this one here and this one here are about the same distance apart. So I know that they're going to go through the 0 there. Okay, the distance here versus the distance here, well, the distance in the bottom looks bigger. So my graph is actually going to go down a little bit before it comes back up. And then the gap in here is bigger than the gap in here. So the sum's gonna come into the positive like that, okay? And then it's going to keep connecting, and then because this is increasing and this is increasing, means that my function is going to increase like that. And there's my graph. So that's my graph of s of x. We use s in this case for, and you may have guessed it, the sum of my function. So just like with algebraic letters, with our functions, we can call a function a different letter based on what they are. So we usually use f of x for functions or g of x for a second type of function. In this case, we're using s of x just to represent the function is a sum of two others. Okay, that's all it means. So you can use any letter, and we're just using s because it makes sense in this situation. So that's my function, s of x, okay? And so it's the sum of the two. Now, it should be, in most cases, above everything, but if both of the parts are negative, then they will be lower than that in that case, because a negative, and you add a negative, gives you an even bigger negative. So think of like -5 plus -2, well, that's -7, so it's even bigger. Whereas if you add a negative and a positive, then you get something that's in between these two numbers. So this line here is in between, okay, because we've got the positive part and we've got the negative part down here, so it's going to be in between it some way. And then two positives obviously make a bigger positive. So that's another way to think of it. If they're both negative, then it's going to be heaps low. If they're both positive, then it's going to be heaps high, like it's going to be higher than both of them. So see how this part is actually higher than this and this in the same row. Okay, and then if you say had that and that, okay, so that plus that, well, that would give you something that's even lower than those. Okay, so it'd be something that's down here. Okay, so that's the first one. Let's do the second one. So same sort of thing. Start off by looking for your zeros. So we've got a 0 here, and we've got a 0 here. Now, the first 0 is quite easy because it is just here, so I'm going to put my dot there. But my second one, well, that's all the way up here, so I don't really care about that at this point. Okay, so that's the zeros. Now we're going to look for the doubles. So that's here, here, and here. Okay, so zeros are done. So let's look for the doubles, 1, 2, and 3. So the double of here, well, that looks like it's at about 2. So my new one should be at about 4. This one looks like it's at about 3. So my new one should be at 6. So that's this one here. And this one looks like it's at about 4. So the new one for that should be at about 8. So that's about there. Okay. So that's those 3 points done. Okay, so you can kind of see what's happening now. It's sort of going up this way, then back down, and then back up. Okay. Now we've got the sum of 2, so it's going to be bigger than this and this, okay, because it's going up. So this bit's going to go up something like that. And we know that it's going to shoot down here. Now we can see, we'll come back to this side of it in a moment. We'll finish off this other little bit. So we've got this part here, and we're adding this part here. So if we're adding the 2, so 1 plus 2, well, that's about 3. Or sorry, 1 plus 3, that's about 4. So this bit's like going to be about here. So you can sort of see where things are by sort of just plotting points around it. So it's going to go sort of like something like that. Now with the 2 outside points, because this one's shooting up, but this one's going down, we can see that it's shooting up a lot quicker than it's going down. So we can assume that for this one, that the graph is going to eventually shoot up like that in some fashion. And then this side, it's the same sort of thing. So it's shooting down very quickly, but going up very slowly. So we can probably assume that it's going to shoot down much quicker than it's going to go back up. Okay, so, and that gives us our second function. I probably should have done these in another color. But yeah, that's what they look like. And so that's the sum. So we call that the S of x, of f of x, and g of x. Okay, so that's the sum of 2 sketched functions. Now we've got the difference of 2 sketched functions. So to sketch the difference, so this time we're using d of x for difference. See what I mean? Like s of x sum, d of x is difference. So fx minus gx. Now, with the addition or with the sum, it doesn't matter which function you do, okay? They both work. So they're both the same, you know, like if you do f of x plus g of x, it's the same as g of x plus f of x. You can't do that with the difference. So if you do f of x minus g of x, so that's like saying, you know, 5 minus 2, well, that's different to what 2 minus 5 would be. So you need to make sure that they are the same way around. Okay, so basically the steps are pretty much exactly the same, except with a little bit different. So subtract the ordinates wherever possible. So that's what we're doing. So some systematic approaches. If f of x has a 0 at x is equal to a, then the difference is the negative of g of a. Okay, so if your first function looks like that, okay, and it has a 0 at, oh, let's put it in, oh, no, it doesn't really matter. Okay, so here's my Cartesian plane. Okay, my function looks like that. Here's my 0. My other function looks like this. Something, well, let's do a bit nicer, something like that. Okay, so here's the other value here. So f of x is the small one, g of x is the big one. Okay, so this, basically what I'm saying is I'm saying take this value in here and subtract it from that value up there. Okay, so when you do that, so 0 minus a positive number, well, what type of numbers is it going to give you? And it's going to give you the negative value. So in fact, the ordinate that you're going to be putting down is that one there, because it's saying like, okay, you've got 0 and you're taking the negative of this one here. So it's going to pretty much flip it. And so it's the same for this side too. So, you know, if you had the line going like this, okay, and you've got the negative already, well, that's going to flip that one and put it to positive. Now that only works for that way. So that is if the f of x, so the first function is at the 0, and the second function is at the, I can't think, and the second function is at the, is in one of the other areas, is what I want to say. Okay, so that's what that's equal to. So if you have it the other way around, so if the g of x, so the second function is at 0, okay, so you have to actually differentiate between your two functions this time. So if g of x has a 0 at x is equal to a, then the difference is just whatever the original function is. So here's f of x, here's g of x, which is the other line. Okay, so look for zeros of f of x, so here's 1, then g of x, so our difference is literally just where the other values are. Okay, that's all it means. So it's just where they are already. Okay, if the curves meet at x is equal to a, then there is a 0 there. So basically what we're saying is if you have lines that are crossing at some points, so like here and like here, then, you know, if you subtract the same number from itself, then you just get 0. Okay, so the ordinates are just where the zeros are. And if the ordinates are opposite, so why do I keep doing crosses like that? So if we have something like this, where probably this here is about, probably not there, but this is about the same difference from here, okay, then the ordinate is just in the middle, okay? So if they're at opposites, then they are in the middle. The sign of d of x everywhere should be clear now. And okay, so the other thing is with the infinities. So to clarify any vertical or horizontal asymptotic behavior, if f of x is approaching infinity or g of x is approaching infinity, then the difference approaches infinity. That's not right. That should be if f of x is approaching infinity or g of x is approaching negative infinity, then d of x is approaching infinity. Because if you're subtracting from really, really big numbers, so if you're saying, okay, here's my thing, okay, you know, positive value, so this is f of x again, very big positive numbers minus, you know, just small negative numbers is really big answer. But alternatively, if we had it the other way around, so that f of x was like just a line and g of x was a really big, it went down really negative, okay? If you're subtracting really big numbers, so you go, you know, 5 minus a million, or sorry, minus a million, or 100,000 or a million or whatever, that just turns into positive. So basically, the difference between those is something really, really big, okay? So that's what that just means. So that should be negative infinity, not infinity. And then you'll see why I say that in the next one, because if f of x approaches negative infinity, so your first function is going down, but the second one we don't care about. Obviously, very small number minus another number is very small number. Or g of x is positive infinity. So subtracting a very big number means, you know, doing the opposite. We're actually subtracting or taking away a really, you know, we're taking away a big number. It's going to give us a negative. Then the difference is going to head towards negative infinity. Okay, so I just need to fix that one up. If, however, f of x and g of x go in the same direction this time, so not opposites like before, but in fact the same direction, okay, we might not be able to determine what happens with the difference. But again, you can sort of make that judgment. Okay, I can see this one's shooting up a lot quicker than the other one. It's going down. Sorry, I can see that this one's shooting up a lot quicker than the other one's going up. So then I know which way it's going to go. Okay, so let's do example 2 for that one. And it's the same two functions, funnily enough, but we're going to sketch the difference this time. Okay, so f of x is the line. So that's the one that we need to be doing first. And then g of x is the second one. Okay, so I'm basically saying, okay, take this line and subtract the parabola away from it. So first thing first, we're going to start with the zeros. Okay, so I've got the zeros, and we want the zeros of the f of x first. So the only one is this one here. Now that's nice and easy because 0 minus 0, well, that's just equal to 0. So that point is just on that there. Now we're going to be looking for the zeros for g of x. Okay, so this is the 0 of g of x. So f of x minus g of x, as we said. Okay, and because g of x is a positive value, it's going to essentially give me the opposite ordinate. So this is what, at about 2? So it should be down at negative 2 where my value goes. Okay, and so that's my second one. Now we're going to look for the points where they're the same. So at x is equal to 2, we've got where they cross over. So that means that that one goes at the 0. Okay, anything else? Not really. We've got shooting up to, so g of x is shooting up to, so this is, remember, is g of x is shooting up to infinity. So that means that my difference will actually shoot down to negative infinity, remember? So if the second one, g of x, goes to positive infinity, then the difference goes in the negative direction. Okay, now with it on the right-hand side, so on this side here, okay, I can get rid of that. So I've got f of x on the bottom. It's slowly going up, but g of x is shooting up a lot bigger than that. So I know that past here, again, it's going to start shooting down again. Okay, because this one's increasing and we're taking away a really big number. Okay, so, you know, small number, take away big number, leaves me with very small number. Okay, now between these two here, so these points here is probably the trickier points. So we're doing the difference. So we're basically saying, have this line here and take away this part here. So we know between here so the 1 and the 2, is going to be different than between the -1 and the 1, because we're saying basically, here's the positive values, take away a negative value. So we're saying f of x is positive, so like say 4, take away minus numbers. So in fact, that will give us positive or bigger numbers than what we started with. So between -1 and 1, it's actually going to increase by some amount. Okay, so probably something like this. Okay, and then between 1 and 2, it's a positive, take away a positive. So it's going to leave us with a positive. So it's f of x is actually bigger than g of x. So it's a positive, take away a positive, but it's going to be a number that is less than this f of x line here. So when it's positive and when it's negative, okay, leaves me with a line that's bigger than the original function, but then, oh, I forgot to actually do that 0 there. Anyway. Oh, wait, I did, because I said f of x. Oh, no, that should be this one here, because it's f of x minus g of x. God, I'm silly. So that one, let me just redo this line, and I'll just redo this line. So this one should go through this point here, and then come down back to this one here, and then go down like that. And so basically that's what our shape looks like, okay? So make sure you do it in the correct order, because obviously I didn't. All right, so let's have a look at the second one. So we're going to follow the same path, and we're going to do it right this time. So we're looking at all of the f of x's. Where does f of x go across the zeros? So here it is here. So basically that means that the g of x is going to be something in the complete opposite direction, which is that one down there. Okay, so that's that one done. Now we're going to look for the zeros of g of x. So this one here. So that means that this point here is just where that one is. Okay, so we've only got those two values there. We can also see where the lines cross over, and where they cross over corresponds to the zeros. So remember, it's like saying, I've got 5 minus 5. What's 5 minus 5 equal to? I'm hoping that you come up with the answer 0. So there's our sort of main points that we can focus on. Okay, now we need to see what's happening in between. So if I rub out these little circles like this, okay, so now we should be able to look at what's happening between those. So on this side here, okay, what we can see is that we've got this thing going up slowly, but g of x is going down very quickly. So remember, g of x is the second part. So if it's going to the negative, what's actually happening is that it is shooting off to infinity in that direction there, just like that. Okay, this one down here, so we can already see what's happening. This one, it's g of x is shooting up, so the opposite is that it's going down like crazy. And you can already see that just by having that 0 point there. So we know the 0 point is the opposite, and so that one shoots down to the opposite like that. Okay, so something like, let me draw that again, something like that. So always the hardest bit is what's happening in between. So we know that we've got these points of 0 here, okay? So in this section here, so between this point and this point here, we've got two positives, okay? And so f of x is bigger than g of x. So it's basically like saying 5 minus 3. So they're both positive numbers, but we're subtracting 2, remember? So that's like 2. So this one's going to come, it's going to come down something like this, okay? Probably something like that. I'm just trying to sort of make it the line look a bit nicer. Okay, so something like that. Oh, I was going to use a different color. Oh, well. Okay, so it's going something like that. Then what's happening here? Well, g of x is bigger than f of x. So that's like saying, okay, 5 minus 7 now. Or in this case, it looks like 3 minus 5. So it's like, what, about minus 2? So in fact, this part here is actually coming down like that. The biggest gap is probably here. So the biggest gap down here should be like that. So this one comes like that, and then it shoots back up to where the 0 is. Okay, and then this bit here, we've got a bigger number minus a smaller number, just like we had in the first bit. So it's going to come back around like this. Okay, and there we go. And that makes our difference graph. So that's the first two done, and we've only got the product to do. So sketch the... Oh, we've actually got to do the theory first. I forgot I'm doing it this way for this one. Okay, sketching the product of two sketched functions. So to sketch the product, it's pretty much exactly the same thing, except with just a few different rules as well. So the product, so P for product, pretty cool. We also use P for polynomial, so just don't get those ones confused for this one, but P for product of f of x times g of x, or f of x g of x, of two sketch functions. So multiply the ordinates wherever possible. That's what you're trying to do. You're trying to multiply those y coordinate parts. Now, easiest way to do it. If one curve has a 0, then P of x has a 0. What's any number times by 0? 5 times 0? Well, that's just 0. So wherever either of the functions has a 0, your function is also equal to 0. If one curve meets at y is equal to 1, so, okay, here's your two lines, and it goes whoop, and one of them meets at 1, so where y is 1, so along the 1 value. So this one, and this one, and this one. So wherever it meets there, then the ordinate of P of x, so the one that you're trying to do, is just whatever the opposite one is. Because remember, if we're doing stuff like 5 times 1, well, that's just equal to 5, minus 7 times 1, whatever it is, it's just the opposite of what it is, okay? So in this case, it would be, this one give you a point there. Why is there so many bells going? That one gives you one there, that one gives you one there, this one gives you one there, and, well, this one gives you one down where it's, the other one is, so wherever that is. Okay, so if you're timesing by 1, you're basically just timesing by 1. If one curve's made at -1, and then the ordinate of P of x is the opposite of the other ordinate, okay, just because, 5 times -1 is equal to -5. That sort of theory. So again, I won't draw this one because it's pretty much the same as the other one. You just put it in the opposite direction. Now, if f of x and g of x are on the same side of the x-axis, then P of x is above the x-axis. Two positive numbers above. Or two negative numbers. Okay, so if they're both positive or they're both negative, okay, two positives is equal to a positive, two negatives is also equal to a positive. So you just gotta be careful with that. When they're on opposite directions, then they're on the negative side, or they're below the x-axis, okay? Just like, two positive and negative make a negative. Okay, for the asymptotic behavior for this one, so if x is approaching 0 or g of x is approaching 0, then P of x is approaching 0. So if something's getting really, really, really close to 0, then that means that your function's getting really, really, really close to 0. So the product of the two is getting really, really, really close to 0. If f of x is going towards infinity or negative infinity, or g of x is going to infinity or negative infinity, then P of x is going to infinity or negative infinity, depending on the sign of g of x. So if they're the same, they're going up. If they're different, they're going down. So if f of x goes towards infinity and g of x goes towards infinity, then P of x goes towards infinity. However, if they're different, so f of x is going towards, say, negative infinity, and g of x is going towards infinity, then P of x would be going towards negative infinity, because a big number times a negative big number is a negative big number. Okay? So, your multiplication rules still apply. Aren't you glad that you learned how to do indices, how to multiply and add and subtract negative numbers in year 7? See, it's funny how all this stuff, even though that stuff seemed really easy and is completely irrelevant now, like how it just sort of, those rules still apply to this really hard stuff, which I just find cool. But, that's also because I'm partly weird. Anyway, let's do our examples for these ones. So, let's look for the points where the graph is 0. So again, we've got the same ones. Here are all my 0 points. So that means that my ordinates are at those zeros. Okay, because whatever number it is times 0 is just 0. Now we're going to look also for where my values are equal to 1 and -1. So what I'm going to do is I'm going to put in a little line myself, approximately where I think 1 is and approximately where I think -1 is. Okay. So basically any value that goes through those, okay, so if either of my functions go through those, so if they go through 1, then it's just whatever the other one's equal to. If they go through -1, then it's whatever the other one's equal to. So, sorry, it's the opposite of what the other one's equal to. So let's look at my 1 values first. That's this one. This one probably actually goes through the axis here, I'd say, and this one here. Okay, so those ones go through 1, so the ordinates are just equal to whatever it is opposite. So this one, the opposite is down here, so put a point there. The opposite of this one is here, just below -1. And the opposite of this one here is above, so it's there. Okay. So that's that one, that's that one, and that's that one. So that's my one line done. So I can remove the one line. Now the negative one line says if there's anything that goes through that, then I just do the opposite of what the other one says. So I've got one value here that goes through negative one. So I look for where my other one is. Okay, so well, that's about that far away from 0. So if I was to flip that distance there in this direction, then my value is about there. Okay, and so that's pretty much it for those ones. So I can remove that. I can remove my line. Oops. Okay, so this one has a lot more ordinates happening before we've even gotten the others half. So now what we're going to do is we're going to look on either side. I'm going to look at what's happening with the infinities and the negative infinities and stuff like that. So this one's going to infinity, this one's going to infinity. They're both the same, so that means that this one here is also going to shoot off to infinity and beyond. This one's going to positive infinity. This one is going to negative infinity. So that means that my product is going to negative infinity. And as we can see with that one there. So this one, even from there onwards, it's about infinity. In fact, I will do it properly. So from this ordinate down, it's going to negative infinity. So remember, positive and negative make a negative, and positive big times negative big, doesn't matter how big they are, will always be a negative big. Okay, now let's see what's happening in between. So from here to, there's another 0. Why did I have a 0 for there? I'm pretty sure I had a 0 for there. Pretty sure I had a 0 there. Hang on, let me just find where I was. So 1's about here. So it's there. Pretty sure, maybe not. Okay, I'm really good at missing these. So just be really careful that you do have everything before you sort of start. Oh, I was going to do a different color. Damn it. All right. So I should also have a point here at this 0 here. Okay. So from this point here to this point here, I've got 2 positives. So my product of these ones is also going to be positive. Okay, but it's going to go like this because this is like, it's a number multiplied by another number. Okay. So it's going to go something like that. Now this one between 1 and 0, we've got a positive times a negative. So it's going to go something like that before it comes back up. And then we've got between this one and this one here is a positive times a negative, but it's not as big this time. So it's going to probably come along like that. Okay, here, positive times a negative again. So it's going to go something like this. Okay. So as you can see, it does get a bit messy, these product ones. And then this one's going to then come back down like this. Okay, so it looks something like that. So that one's a bit of a mess, but I mean, they are going to be for your products. They are a little bit trickier, but that's how you do the product of 2 functions. Let's look at the second example and I'll try and get this one right. And you know what? I'm even going to be nice and I'm going to change the color for this one. Look at that. I'm going to do red. So what we're going to do first is going to look at all our zeros. So we've got 1 0 here and we've got 1 0 here. So if we've got zeros, then that means that my function, or the product of the 2 functions at that point, is just 0. Okay, now I need to go through my 1s. Okay, so if I go along here like this, and my negative 1s as well. Okay, so remember that's just an estimation, it's not exact, but you're looking for all your values, so I'm going to put open circles for all your values where it's equal to 1. Look at that one's pretty much on top. Okay, like that. Now remember, when it's equal to 1, then the ordinate is just whatever the other one is, because like 1 times 5 is equal to 5. So whatever that number is at the end, okay, it's just going to be what it's equal to. So that one has an ordinate there, so let's rub him out. This one has an ordinate here if it's at 1, and this one has an ordinate on itself if that's at 1. So there. Okay, is there a negative 1? There is one at negative 1. So probably here, so that's like this point here. So what happens is this one comes down like that then, and that gives me my, oh, sorry, it's like down here. So it's the distance like that. So this one's like here, all the way down there. Okay, like that. Okay, so the product, and as you can see, like this one's shooting down heaps quick, like really quick. So our one's going to shoot down really quick too. Okay, I'm hoping I've got all the points this time. And any double ups? No, we don't do double ups in this one. Okay, so now we're looking for the sign or the value of each of these. So we've got what? So this one comes down like this. Okay, like that. In between those, these ones here, well, it's a big times a big, so it's going to come up like that. Okay, and then shoot down like crazy like that because it's a positive infinity and a negative infinity. Positive times negative is a negative. Now this one here, we've got negative. Well, we have, so in between here, we've got very big. So what happens is basically it goes like this. Okay. And then it shoots down to negative infinity as well because we've got positive infinity, negative infinity, so it's going to go to negative infinity. Okay, and that's basically that one. So, I mean, like, these drawings aren't great, but it's a sketch. Like, it's a general sketch of how do you do it. Like, what I'll be looking for is that you've actually made these sort of markings on where they are and where those values are, okay? That's the thing that we're looking for in this case. But with that being said, that's pretty much it done. Any questions, let me know, and I will see you in the next one.